So I'm sure everybody knows, but as of October 1st, which is coming up in 1 week, or math serves me, 1 week, you have to be vaccinated to come to school. I'm not sure how they're working that. I haven't followed it all that much, but I'm sure you're all aware of it. Just throwing it out there. And let's go to safety. Let's do the safety meeting. Meeting about safety. Talk.
It's all the way off or just halfway?
All the way, please. It's pretty light. Pretty light. Where are we going? Okay, sorry. The best part about being funny is cracking yourself up. Okay, this is apropos because we demonstrated construction lasers Tuesday in class, and a lot of you were in there in that class for that demo. I guess that would help too. Let's give it a minute to warm up so everybody here can see this page. Who just came in?
Miguel.
Miguel?
Yeah.
All right. We're just gonna call you, man. Showed up. Good work, Miguel. How about Austin? You show up? No? Eric? Joel? Warm up yet? We're there. I'll read the introduction. There are many variations of construction lasers, and each one can be a time-saving device if used properly. Looks a lot like the one we have. Employees who use construction lasers at work are required to be properly trained and to apply all safe work practices in order to avoid damage or injury. John, would you read types, please?
Types. There are many types of construction lasers, from measuring devices to leveling devices. Employees must know the difference between the lasers in order to choose the correct tool for the job. Laser distance measure. These tools use a laser beam to automatically measure distance. Basically, this is the laser version of the tape measure.
Okay, stop for just a second. So, do any of you have a laser measuring device? You have one?
Yeah.
You have one? Are they pretty accurate? Have you?
Seems to be, yeah.
Feel accurate? Would you use them and trust them as much as you trust your tape measure?
No.
Okay. I wonder about that because I mean, if you don't know about them, that basically that you put them against something and then fire it up and whatever it bounces back at, it gives you a readout.
I just wanted to measure the heights of trees before, which is kind of cool. I don't know if you've ever seen those.
No, I have not seen those.
Yeah, I work with an arborist, and we take a shot of the top of the tree
Yeah,
and then the bottom of the tree, and it uses the
it triangulates it.
Yeah, it's pretty cool, but
That's-
it's not super accurate. It's accurate to maybe 5 or 10.
That is cool. So did you guys hear about that? Did you just hear what Lou said at home? Zoom people? About that laser device that measures trees? Oh, I love that idea. So Louis just described to us the device. You would sight it top of the tree and bottom of the tree, and then it would triangulate to the height of the tree. Which reminds me that when I was working for CDF, which is now Cal Fire, I took a class so many things to do at once. I took a class in get one light. I took a class in timber cruising. So in timber cruising, timber cruisers, guys that are usually independents that do this, they work for they basically work for the lumber companies, like Weyerhaeuser is one of them. Just one to name just one of many. But they hire timber cruisers, or timber cruisers work for the company to cruise through forests and decide which trees get logged and decide how many logs are in a tree. And to do that, they have to decide, they have to figure out the girth of the tree, that is the diameter of the trunk, and the height of the tree. And they measure it in 16-foot logs. Logs are 16 feet. A log is a 16-foot increment. So before we had laser measures or any of that stuff, what we had was called a Biltmore stick. Yeah, a Biltmore stick. And a Biltmore stick was a nice cane, nice piece of maple hardwood. And you can still get them, I'm sure. And it had increments on it on 4 sides. And to get the height of a tree, you would go to the base of the tree and step back. I think it's 50 paces. I can't remember exactly. Turn, hold the thing up at eye level, right? And then with your eyes, without moving your head, you read the top of the tree, and that gives you the height of the tree. And you divide how many logs are in the tree by that. And then it's so many feet back from the trunk of a tree, you hold the stick like that, and you sight edge of the stick with what it comes through here to give you the diameter of the tree. And with those numbers, you can figure how many board feet. So basically, good lumber cruisers with this Biltmore stick could walk through a forest and tell you how many board feet were loggable in that forest. It's a pretty cool thing. And you don't even hear about it anymore. I'm sure none of you have ever heard about it. And you don't hear anybody even mention it. So I wonder if it's even used anymore. I suspect it is, but I don't know that for a fact. So let's go back to the safety meeting.
What did it say was the name of the stick again?
It's a Biltmore stick. Yeah, and when I get a screen, I'll pull it up. Okay, so let's go back to where we were. Was that you reading, John?
Yeah.
Once you finish those.
Second.
Rotary.
Yeah, we got the
Oh,
little
sorry.
warning thing.
Oh, yeah, of course. Forgot about that. Is it what? Oh, man, I can see it just perfectly. What's the problem? Okay, reminder.
Okay, rotary laser level. The rotary laser level is positioned in the center of a room or job site and emits a laser beam which rotates rapidly in order to create a steady line that is projected 360 degrees.
And you guys all saw that. Well, not all of you, but some of you in that class Tuesday night saw that one. Go ahead.
Line laser level. These lasers project horizontal or vertical laser lines over a specific distance.
And you saw that too.
Plumb laser. The laser version of a plumb bob. This self-leveling tool is attached to a point of interest and projects a perfectly plumb laser line. Pipe laser provides a solid line to ensure projects are plumb and aligned correctly.
And I don't know what a pipe laser is, but I suspect it's a plumbing tool for larger pipe installations, gas pipe, stuff like that. I guess. I don't know. I've never heard of a pipe laser personally. So, Miguel, would you read requirements, please?
OSHA requirements that the following safety rules are met whenever a construction laser is in use. The only qualified employees are permitted to install, adjust, or operate laser equipment. Operators must be familiar with the class and strength of the specific laser they use. Employees must wear anti-laser eye protection when working in the area for potential exposure to direct reflected laser light is greater than 0.005 watt, 5 milliwatts. Area in which areas in which lasers are used shall be posted with laser warning signs and labels. Beam shutters or caps must be utilized where available. Employees must turn the laser off anytime laser transmission is not required or when the laser is left unattended for any period of time.
Yeah, it's pretty important. So, Michael Silva, would you read the next 4 bullet points? And then, you know,
Yeah, the laser beam should never be directed at another person. When it's raining, snowy, dusty, or foggy, the operation of laser systems is prohibited. All laser equipment must bear a label to indicate maximum output. Employees are never to be exposed to light intensities above the following: direct staring, 1 microwatt per square centimeter, incidental observing, 1 milliwatt per square centimeter, and then diffuse reflective lights, 2.5 watts per square centimeter.
I have no idea what any of that even means. In conclusion, when all safety requirements are followed, lasers can be extremely helpful in time-saving devices with minimal risk for injury. In addition to following the safety requirements listed above, you must familiarize yourself with the specific model you will be using and the manufacturer's safety recommendations to ensure that you're using it correctly. Do we have any comments? Comments on this?
Yeah, did you say you don't know what that those three or limits mean?
No, I don't.
I think I have an idea.
Good. I want you to tell me in half a second. So there's a pipe laser. Yeah, which is what I figured. I figured just go in a trench on top of a pipe and tell you if the pipe's running level or how much downhill it runs, just like that. So that's for larger piping jobs. So Zach, go ahead. Yeah, if we back up, what I don't know about is this microwatt per square centimeter, 1 milliwatt per square centimeter. I don't even know what's dangerous about these lasers in terms of micro or milliwatts per centimeter. So can you elucidate on that?
Yeah, so I mean the micro watts per square centimeter, those are measures, or watts per square centimeters would be measures of light intensities. And then the three different classes, direct staring would be looking straight into the beam, projecting into your eye.
Yeah.
Incidental observing, it's like seeing it go across, like in that
Yeah.
picture there.
Yeah.
And then diffused is as it bounces off walls and stuff.
Yeah, I always thought that much is pretty self-evident. It's just what is a microwatt?
Let me,
How much so I guess it's incumbent upon me if I'm using the laser to figure out and find out who just walked in.
Oh, well, Santos?
Oh, well, all right, thanks, man. It's incumbent upon me as the user of the laser to figure out and find out what it projects and where is the point in which it's detrimental. I just know you never want to stare at a laser. I mean, if it goes across your eyes, you're going to be okay. I know because it's crossed my eyes multiple times over the years, and I haven't suffered anything other than my eyes are, I think, naturally aging. But I'll find out because it's kind of stupid for me to have a safety meeting with you and not even know what really what the real hazards are. I just know you're not supposed to look at them and you're not supposed to keep them on the job site so that they get looked at inadvertently, or if they're just bouncing around all the time. Because I know you can really do damage to your eyes if you stare at them. So don't stare at lasers. And as you can see, this tool here, the picture that's up, that's one. I'm not sure what that guy's laying out yet, but you can see he's on a pole tripod, extended tripod. It looks like it's relatively easy to move that thing up and down to get it to a level line or to project that line around the room where you want it, versus where I told you the other night, where most of the indoor stuff that we do, like establishing a line, it doesn't really matter where that level line is. It's just an index. So you get a level line and then you index to where you want level and you use that index number from your level line. But this is a pretty cool way to do it too. And like I said, for some of you that weren't there on Tuesday night, is that when you're using a laser that projects a level line around a room and you're running something like, well, for instance, you might be hanging jams in a hallway, both sides of a hallway, jams, windows. So you want all the heads of those doors, windows or doors, to plane out. And a really good way to do that is to get a laser line right at that head, either at the bottom of your 3/4 or 5/8 jam or the top, either one, probably at the bottom inside, and then just set every jam to that actual line rather than measure it each time. And with a tripod like that, it's pretty easy. You can see with the tripod, when we set it up, you can't really go up and down with that tripod, and there's no real vertical adjustment. So this tripod is something I haven't seen before, but I see now exactly why it's used. I like it. So any other questions about lasers?
Any difference between green and red?
Say it again, please.
Any difference between green and red?
Yes, a lot. How did you know there was a difference?
Well, I'm just asking if there is a difference towards.
No, I
red.
mean, how did you know there was a green and a red?
I've seen them on site.
Okay, okay. So Tuesday night, John demoed his green laser. Green lasers cost a little more, and I'm not sure exactly why, but they're way easier to see in daylight and brighter light. You can see them in daylight, whereas red is almost impossible. You have to have a receiver. Now, the green laser light will take a receiver, audible or visual receiver, and red does too, but the green you can see outside unless it's really bright. That's the difference.
Both would be damaging, like.
But both would be equally damaging to your eyes. Yes, absolutely. Any other questions or comments about that?
So the one that John brought was was it the third one down there?
Yeah, the one that John brought was
Where's the one that you set up as the rotation?
would be in the class. Where are those?
Was it the plum laser?
The plum laser. Well, not really. It's a line plum because it projects a crosshatch line. It projects a level line.
Yeah.
And a plumb line at the same time. And it also, the prismatic effect of it shoots that line all the way around the room without it spinning.
So is that the next one up the line laser level?
Yeah, I think that's the line laser level.
And then the one that you set up is the rotary laser?
That's the rotary laser level. So the laser distance measures are usually about that big or handheld. You put them against something and then press the button and it gives you a readout. What they are. They're not that expensive. You can get them for $100. More and less. But rotary is like the one I demoed. It spins like the one you see there, like that one and that one. And then the line laser and plumb lasers combined in that Bosch that John had, which is really a cool tool. And it was $550, so it's not a cheap one either. But you buy a tool like that, you should have it for your whole career. Now, being a contractor, I have my own set of tools. And then as I did more and more work, I did less and less physical work with the tools until there was a point where I just couldn't work with the tools anymore. I didn't have the time because I was running the work and running employees. So my company bought laser mills, and I've owned 5 of them because they've been stolen. They're hot tickets to steal. So where are we here? Let's go to modules. We had the safety meeting. We're in week 5. Oh yeah, I want to show you this. Can somebody come in? Is that you, Lay? Austin? Okay, Austin's here. How about Eric Mendez? Did you show up? Eric? No. Okay.
Yeah, right here.
Eric, you showed up on Zoom?
Yeah.
Right on. Yeah, if you guys ever come late, especially on Zoom, if you're 10 minutes late or something like that, chime in and say, hey, it's Eric and I'm here, because unless I remember to make sure I mark you here. Okay. Okay. I got to show you something really cool. So I just got this wild hair. The other day. And I bought this car this morning. I ordered it this morning.
What color?
That color right there. Glacier white. It's for my wife. She really wants a white car. Glacier white with a black top and the 20-inch wheels and the projector LED lights. And it's, oh man, it's just beyond belief. Like it's this giant, the whole roof is glass. The whole roof is tinted glass. And it's got a sun shade, right, that retracts it. And to make the shade happen, you either hit the the ear and say retract the sunshade that says retracting sunshade, or you take your finger and just swipe it along this little thing on the roof and it goes. As your finger goes like that, it goes. So if she'll let me, when I get it in 3 to 6 months, when she gets it, I'll drive it. Of course, we won't have the class in 3 to 6 months. Yeah,
Is that an electric?
it's all electric. Yeah, all electric. It's 260 miles on a charge, which is one of the reasons why I was so stoked about it, because you can drive to LA and around LA and back. You can drive to San Francisco, one stop is King City. You can get to Vegas. You can do all kinds of stuff. And everything on one charge, and it comes with a 110 charger that takes charges overnight. It's a 12-hour charge. And the guy, the salesman, said to me, "Oh, well, yeah, you can get it comes with a charger, a 110 charger, but get a 240 charger, a fast charger. Pay some money and get your car charged in 6 hours." My car, I go to sleep, my car goes to sleep. Wake up, I'm charged, car's charged. Easy stuff. Almost never drive at night anymore, except home from school. But yeah, I'm just stoked. I haven't bought a new car in a long time, and I think I'm going to lease it. But there's that.
How safe it is?
Say again, please.
How safe it is if it's in an accident and it just.
Who cares? You hope you die, right? You're in a bad accident. It has good safety features that I know of. I mean, I'm not sure, it's got ABS and all the other safety features and side airbags and airbags.
Right.
It doesn't have, the batteries haven't caught fire. Some electric cars, batteries catch fire. So it's if you research the car at all and you click on a video done by Volkswagen, it's a guy, a German-looking guy with kind of white flat top of fenders in his 40s, very erudite, and he's a personable speaker. And he tells you what's going on with the car and what's going on with Volkswagen, because Volkswagen took that big hit about 5 years ago, where they were lying to people about this chip, and they tanked, but they have come back really strong, and they're touting this car as the new Beetle, an affordable, cutting-edge tech. Because when the Volkswagen Bug came out, it ruled the world. I mean, it was one of the better things that ever happened. It was an affordable car. I used to fill up my 61 Volkswagen for, it was like, it went for $2, $2.50, $2.50, because gas was 25 cents a gallon. I had a Volkswagen in Venezuela on Islas de Margarita in 2005 or 6, and I went to fill it up, right? I've been driving it all over the islands. Islas de Margarita is this big, pretty good sized island, 200 miles off the coast of Caracas, Venezuela, and it cost me $1.21 to fill it up. It's 11 cents a gallon gas in Venezuela. Anyway, I'm stoked about Volkswagen. So who do you know what else Volkswagen owns? Volkswagen owns
Audi.
They own Audi, they own Porsche, they own Bentley, they own Lamborghini.
Yeah.
They're unreal. They actually bought Rolls-Royce in 1999, but they didn't buy the name, so they can't manufacture under that name. Too bad. So yeah, I'm pretty happy about it, because a happy wife is a happy life. Like I said, occasionally I bet I get to drive it.
My dad bought a shirt in Vegas that says that. And
How did that-
it always cracks me up.
That's what it says. How did I do this? How did I possibly get this so small? All right, you guys, bear with me. I want to get this back. I don't know how yet. Do we have any Zoom mavens in here? No Zoom mavens?
What's going on? What do you want to do?
I'll figure it out. I promise. I was just trying to get that back up, but I think I might still be on. Yeah, I'm still sharing my screen, right?
Yeah.
Okay, good. Let's let's look at our textbook, because we're gonna do some really exciting stuff. And that's not where we see it at. Yeah. Okay. So we've waded through adding and subtracting fractions, and now we're on multiplying fractions. Everybody see that? Okay, good. And then as we get into this, we're going to get to a page that's going to show you some balustrade spacing, pickets or balustrade in the fence, or a baluster, and I'm going to stop. And I'm going to show you something on the board too. Okay, so the objectives after we go through this chapter. Starting this unit, we're going to demonstrate the method of used to multiply fractions, multiply mixed numbers, multiply more than 2 fractions, and multiply more than 2 mixed numbers. Process of multiplying fractions is much easier than adding or subtracting because common denominators are not required. So we don't need to do LCD. We don't need the lowest common denominator, which we need to do before we add or subtract. We can't add uncommon fractions that aren't the same. So to multiply 2 fractions, you simply multiply the numerators to calculate the numerator of the product, and then you multiply the denominators to calculate the denominator of the product. Product of this operation is reduced to its lowest terms after you come up with the answer of multiplying the numerator at the top to the denominator at the bottom. Then you reduce the lowest common denominator. Or you reduce it to its lowest terms, not to the common denominator. Before mixed numbers can be multiplied, they must first be converted to improper fractions. And so if you remember, a mixed number would be something like 1 2/3. You'd have to reduce that to an improper fraction to be able to multiply it. So 1 2/3 is expressed as an improper fraction is 5/3. You see how that's done? And it may be clearer, and it shows it fairly clear. Fairly clear too here as we go ahead. The height of a set of stairs can be determined using multiplication. The vertical distance from one floor level to another, total rise, which we're going to remember total rise. Remember total rise, total run, unit rise, unit run, because we're going to lay out stairs, not for a while, for a few classes yet. But if you can get that, you will be so far ahead of this carpenter game, because it's a real good basic thing to know in carpentry, and not everybody knows it. Well, if you're a carpenter, you should know it. So here's the sample problem: 7 1/4 risers times 4 equals 29 quarters. So you can see that to turn 7 1/4, which is a mixed number, and we need to turn it into an improper fraction. We just multiply the denominator, 4, the bottom, times 7, the whole number, which is 28, and then we add the numerator, which is 1. So 29/4 times 4, which is 4/1, equals 116/4, which is 29 inches, because 116/4 is expressed the way I like to, which is 116 on top, 4 on the bottom, means that the top number, the numerator, is divided by the denominator. So 4 into 116 gives you the whole number, which is 29. So the method used to multiply, this is interesting, because we're going to get to a multiplying mixed numbers here, and I don't know why they have included that, but the method used to multiply fractions is, when multiplying fractions, the fractions are typically arranged horizontally, multiplied and reduced when needed. So in a typical example here, 7/8 times 3/4, we just multiply right across the top. The numerators are 7 times 3 is 21. The denominators are 8 times 4 is 32. So it's 21/32. And that reduces, doesn't it? No, it doesn't reduce, I'm sorry. So it's 21 30 is the answer to that, and that doesn't reduce. If it were 22 30, what would it reduce to?
22, 32.
22 30 would be reduced to 11
Half.
16ths, right? And we'll get to that too. So once a multiplication problem is set up, the ability to cancel numbers in a fraction can reduce the size of the numbers we multiply. Canceling is the only place I know where we cancel numbers is in multiplication and division of fractions. So here's how we do it. To help see this, combine the two fractions as a single fraction. So here's the example: 3/16 times 32 33rds. So you'd go, it'd be 3 times, so 3/16, so it's 3 times 32, and then 16 times 33, right? But you can make it simpler than that. You go to down below, before multiplying the fraction, look for any opportunities to cancel numbers that will divide evenly into the numerator and the denominator. So you're going to look for a number that will divide into the numerator and the denominator, any number. And if you can get that, then you can do some canceling. So after each reduction is made, look for other opportunities to simplify the problem until the fraction has been completely reduced. Once completely simplified, then perform the multiplication. So here's how this is canceling, has reduced some of the math. So that 3/16 times 32 32, written like that, we can take the 3, which we know goes into 33 11 times. We can make the 3 1, and we make the 33 11. And we have canceled all we can. So then we go 1 times 2, 16 times 11, which is 176. Wait, I'm sorry. It's not 16 because we reduced to 16. It's 1 times 11. So the answer is 2/11. You see that? We're going to do a few more of these because it might not register with some of you how the canceling works. Always look for opportunities to cancel number and fractions before multiplying, then reduce the product if needed. You don't have to cancel. You don't have to cancel. We could do the same thing there. We could do, instead of canceling, we could do 3 times 32 is 96, and 16 times 33 is whatever the hell it is. And you're going to have a giant number, and then you're going to reduce that to the lowest denominator, right? But canceling makes for simpler math. But all this stuff in multiplying and dividing most, especially oddball fractions, doing it on paper is the best way to go. I don't do a lot of that. I use some of it in my head in fractions, but doing it on paper is the way to do it. Now, why they felt the need to put this paragraph in here is beyond me, because I'm gonna read it for you. Multiplying mixed numbers. When multiplying mixed numbers, they must first be converted to improper fractions. Be sure to check the improper fractions for any opportunities to reduce by canceling. Once the multiplication is complete, convert the product back to a mixed number or use if needed. This is not the one. So yeah, no, it is. It is. So you can't multiply mixed numbers. So you can't multiply 1 and 23 32 by 4 and 7/16. You can't do it. There's no way to do that. You have to turn them into improper fractions. So you can't multiply mixed numbers without converting. And then you can cancel and reduce as well. So here's an example. We're going to take 3 5/7 times 2 3/4. So the first thing we're going to do is we're going to change those to improper fractions. 3 5/7 becomes 26/7. Everybody see that? 2 3/4 becomes 11/4, which is 4 times 2 is 8, plus that 3 gives you 11/4. So now we're going to do some canceling. So instead of 26 times 11 and 7 times 4, 26 is divisible by 2 as well as 4. 7 and 11 aren't divisible by anything. Those are prime numbers. So 4 divisible by 2 makes that a 2. And that 26 divisible by 2 cancels it, makes it a 13. Now we're dealing with 13 times 11 over 7 times 2. 13 times 11 is 143. I can actually do that in my head because 11s are pretty easy. Just take that 13, make it 130, and add 13, 143. Add one more 13 over 14. So And then that's got to be turned into an improper, into a mixed number, 143 over 14. And by doing that, we take 14 into 143, which is really 10 and 3/14 left over. That's pretty easy to see in your head, but you can do that on paper too. See how I did that in my head? 143 over 14 is pretty easy because I know 10 times 14 is 140, and it leaves me 3/14. So that's pretty simple. Multiplying more than two fractions. So the process for multiplying more than two fractions follows the same pattern described above for two fraction multiplication. The fractions are combined into a single fraction. Numbers are canceled if possible. The numerators and denominators are multiplied and the product is reduced if needed. So here we go. We're going to go 7/16 times 6/7 times 5/8. We're going to change them to, well, we're not going to change them. Let's say we are. We're going to express them just like they show right there. 7/16 times 6/7 times 5/8. So 7 times 6 times 5 and 16 times 7 times 8. But we can reduce because 7s are divisible by each other. So 7 goes into 7, 1, that becomes a 1. This 7 becomes a 1. Now we're going to reduce it even more because 6 and 16 are divisible by 2. So that 6 becomes a 3, divisible by 2. That 16 becomes an 8 divided by 2. So now we're going to do 1 times 3 times 5 versus 8 times 1 times 8. Now, would you rather multiply 7 times 6 times 5 and 16 times 7 times 8? Or would you rather do 1 times 3 times 5 and 8 times 1 times 8? Any day, the latter. So 1 times 3 is 3, 3 times 5 is 15, 8 times 8 is 1. I'm sorry, 8 times 1 is 8, times 8 is 64, so 15/64. Easy peasy. When multiplying more than two mixed numbers, the mixed numbers must first be converted to improper fractions and combined within one fraction. So you can do multiples of it. You can just keep multiplying, right? Keep reducing, keep multiplying. You can keep going. So here's another example. Here's another three mixed numbers to be multiplied. We're going to multiply 3 1/16 by 4 4/7 by 3 3/4. Now, I'm not sure how you ever deal with these fractions. They're certainly not going to be inches or parts of yards and stuff like that, but you can never tell. And that principle is the same no matter how you're doing it. All right, we're taking a break. We're taking a break right now, and we're going to come back. I got 12 to come. Take a nice healthy break. Come back at 5 after. Thank you very much. 5 after. I'll stop recording. 5 after. Come back at 5 after. Okay.
Okay.
Thank you. Guys and girls, come on back. Please. Please come back. Come back, come back, come back. We're gonna stop for just a second. So come on back for break, you guys. We're gonna stop the textbook, we're going through the textbook briefly. So I can show you, what kind of problem for Ben.
Are you gonna record or no?
Say again?
Are you gonna record?
So Zach, Dylan took your job and now it's,
I really stopped recording.
oh, I never paused.
Oh, there it is.
I'm gonna get this. I swear I'm gonna get this. Well, I feel sorry for the people that have to fast forward, if we can fast forward. So this is what Ben gave me. He gave me a drawing sketch, not to scale. And what it looks like is it's a pool surrounded by a deck. And the area in red, that's where you want the gravel, correct? Okay, cool. And how thick? How much gravel?
So let's say, because he said it 1.5 to 2, so 2 inches.
2 inches, okay. Use my new pen. Paduke, yeah, I was gonna say that. I'm gonna ask you if it was Paduke, and it is. So 2 inches thick. So what we got is we got a bunch of rectangles.
2 inches isn't very thick with gravel.
No.
It's not. You might see the ground through it. I want to go a little thicker.
We're using this
Weed cloth.
weight cloth.
Okay. Yeah.
So it's
Let's
sort of
not,
darkens.
Luke, let's not confuse the issue.
Sorry.
Say 2 inches.
Sorry.
Okay, so what I'm seeing here, just to give you guys the overview too, is a pool kind of in the middle. It's got, this is 5 feet, this is 5 feet, this is 5 feet, this is 5 feet, and this is 28 feet. Right? So let's take this rectangle, which is 5 by 28. This rectangle, which is 5 by 28. I guess we could just go 10 by 28, and that would take care of these 2 rectangles, right? And then these guys are going to be, it's 60 overall, so this is 50. So 5 by 50, so 10 by 50 equals 500, and 10 by 28 equals 280. So it's 780 square feet, right? So it's 28, and 28 is 56, and 100 is 156. 156 times 5 is 780. You know how I know that? 156 times 5. So in my head, I'm going 5 times 15 is 75. 5 times 15 is 75. So 5 times 150 is 750. I can hold on to that number. 5 times 6 is 30. 30 and 100 and 750 is 780. So so I proved it to myself that it's 780 square feet. And now we want to know how many cubic feet, so we can turn it into cubic yards. Right? So it's 2 12s. So let's multiply the fractions. But I don't want to turn that into, I can turn that into a fraction, sure. Why not? So 780 over 1, right? Times 2 12ths. Is that right? 2 12ths. 2 inches is 2 12ths because there's 12 inches in the foot. We want to know the cubic feet. We're getting the cubic feet here. So can we cancel anything? I think we can. I don't know that 12 goes into 780. Let's see, does it? 12 does it? 12 doesn't go into 70, 80. So 12 doesn't go into, so, but,
65, it says
but 65, it does go 65 times?
780 divided by 12.
Yeah.
65.
Ah, it does. So we're gonna make that 1, and make that 65 by canceling. 2 times 65 is 130 over 1 times 1, so it's 130. So you have 130 cubic feet divided by 27. What is that? 5. 5 is 135. 5 times 27 is 135. You have 130 cubic feet. I'm going to call that 5 yards if I'm ordering gravel. Because that additional 5 cubic feet isn't going to matter. We're not going to have exact 2 inches of gravel in, right? So there's 5 yards of gravel. And I did that pretty fast. And if I was doing it, I would probably go back and recheck and just make sure before I ordered it.
Right.
But I'm pretty convinced that that's what they need is 5 yards.
So that's
Gravel's sold by the yard.
okay.
Sold by the yard. And in some cases, it's sold by the truck, by the 10-yard truck. Sometimes you do more, a little less, but gravel and concrete are both sold by the yard. And so we just solved your problem.
Thank you.
Yeah,
Always,
it's fun.
always order more, always get an extra half scoop. Doesn't go as far as you think. That's the most.
Thanks for that problem. It's great.
It's a real world.
Real life.
What size gravel?
Keep it right today.
Pea gravel?
So, you know the difference between gravel and crushed rock? Anybody?
What's that?
Do you know the difference between gravel and crushed rock? So there is a difference. So, you know, most people use a 3 HP. Then you go into there's a 3/4 gravel, 2-inch gravel, there's all kinds of gravel. But gravel, like a 3 HP, like a Hanley Gold, for instance, Hanley Gold and 3 HP, Hanley's 3/8. Gravel's round. It's rolled, it's round, it's not square. Crushed rock is not round. So if you're using it in an underlayment, if you're using it like a base for a driveway, like I just built a driveway. If you're interested, I'll bring that. If I remember, I'll bring the section drawings I did, but I designed a permeable driveway in gravel based on a bunch of input I got because I couldn't find anybody that had one. And the city on this plan, that house I just built, called for a permeable driveway. And they called for permeable pavers, and they mistakenly called out the existing pavers as permeable. And then it was adding to the existing pavers to make a hammerhead, turnaround, and then a little wider driveway. But the existing pavers weren't permeable. They're regular pavers laid on 2 inches of compacted road base. So anything but permeable. So we took out all that pavers and we took out all the road base. And we over excavated, I think, down to 8 inches, and then we added back. We went with a geocloth, and then we went with 4 inches of a 3-inch crushed rock. And then we went with a 2-inch crushed rock, like 4 inches of 2-inch crushed rock. And we kept building up. And then we went with, then we were doing this 3/8 Hanley Gold and pea gravel mix on top. But the 2-inch rock, we got some gravel. We got a load of gravel. We got a few yards of gravel with our crushed rock, and it just didn't mesh. And the gravel just kept like, you know, it just doesn't. The crushed rock locks together with this fractured surfaces. The round surfaces have a tendency to leave bigger spaces. So if you're trying to compact it, make it a base, like a permeable base, then use crushed rock versus gravel. And it's funny because I didn't pick up on it, but John Sesser did. And you know, once he showed me, he was sharp enough to pick up on it. Once he showed me, I'm like, no person. So we had to have this guy come and take out, scrape like 3 inches, like 10 yards of gravel, 3/4 gravel. So that's and bring us back 3/4 bushel. And it worked exactly like we wanted it to after that. Exactly. exactly like it.
Rodney, have you ever heard of permeable pavers getting filled in with silt and debris and not being permeable?
No. Because how could that happen? How could silt or debris be non-permeable? In other words, it'd have to be a non-permeable silt or debris. Silt's gonna be permeable, right? Any kind of organic debris is gonna be permeable. So the only thing I can think of that you would get in there would be something non-permeable, would be like concrete, epoxy resin.
Little rocks or-
So whatever debris it got filled up with should stay permeable. But my owner wanted gravel throughout. She wants gravel over her whole property. And it's just, clean. And then gravel will be pulled away, wheat cloth, gravel will be pulled away, hole cut in wheat cloth, and then planting's done. And then gravel put back. And then this permeable driveway that I did, designed with a bunch of, see, I think we used 3-inch and then 2-inch and then 3/4 is what we did. We got about that much gravel. It's about 8 inches. I'll have to get my drawing, pull my drawing out, but what I did is I made a 25-foot wide by 58-foot sump, basically, a permeable sink. And so I French drained the whole house, and I brought all the French drains, all the perforated pipe to that area. I brought all the area drains, I brought them all to that area, and then put the gravel on top. So everything dumps into that, and it gets dispersed in the gravel, and then it goes out in the groundwater. Because it used to be 10 years ago, the city of Santa Barbara and the county of Santa Barbara both wanted you, when you built, they wanted your roof water and all of your any runoff water, they wanted it directed to the street, off the property. Now they want it all on the property. They don't want water to go off the property. So they want permeable structures, they want sinks, they want bioswales, they want all this stuff to keep your water. Your roof water, which used to have to go into a downspout and then daylight to the street, that now needs to go into a downspout and go somewhere where it stays on the property. We want to recharge the aquifer. That's what we want to do, which makes sense, especially with the kind of rain we get. We just don't get enough rain. So it was an interesting exercise.
How much do they spend on gravel?
Lots.
Yeah.
That was 25 grand. Yeah, maybe not that much. Maybe more like 7 grand. Maybe the 25 is more because he did a bunch of excavation and all that. I hauled out 100. I exported 100 yards of dirt.
Wow.
Yeah, exported 100 yards of dirt. It's not a big lot, right? The lot went up like this, and she wanted it as level as she could get it. And my argument to my owner, which was fruitless and stupid, that I always put my 2 cents worth in, is that this is your land. You're not only gonna get rid of it, but you're gonna pay to have it hauled away. It's your land. I wouldn't give away a fucking cup full of my dirt. Not even a cup. My wife has these 5-gallon buckets, right? So what do we do with it? Well, it's gonna go back on our property. We're not giving our dirt away.
Morning dirt.
People are strange. I'm strange. Okay, let's go back to fractions. Back to fractions. What's happening? We're recording. What did I do, man? What happened? What just happened? Oh, okay. Back to fractions. So let's do this, baby. We stopped before we got a chance to do this. We're going to take and multiply 3 to the 16th by 4 4/7 by, and let me get this up for you. Zoom cats. Wait, you can see it on Zoom. You can't see it here. That's what I meant to say. Lights, please. Lights, camera, action. Thanks. Oh, look, it came back up. Okay, so let's do this problema. 3 1/16 times 4 4/7 times 3 3/4. It seems like a complex quotient to arrive at. The first thing we need to do is we need to take those, in the vernacular. So we need to get those mixed numbers, whole number and a fraction, turned into improper fractions. So let's go ahead and make them improper. 3 and 1/16 becomes 49/16. Can somebody tell me how?
3 times 16.
You multiply it.
Is It's 48 plus the 1, 49. Okay. 4 and 4/7 becomes 32/7 because we go 4 times 7 is 28, and then we add the 4 on top. Numerator on top makes it 32/7. And then we turn 3 3/4 into quarters by going 4 times 3 is 12, add the 3 is 15/4. So now we're multiplying 49/16 times 32/7 times 15/4. We're going to do some canceling. It's shown below. So we see that 49 and 7 are divisible by each other. So 7 goes into 7 one time, that becomes a 1. 49 goes in 7 times, that becomes a 7. So then we'll write it down here like that. 7 times 32 times 15, but we're not done yet because 32 and 16 are cancelable and reducible. 16 goes into 16 once, into 32 twice, so that becomes a 1 and a 2. So now we can't reduce it anymore or cancel anymore. We're going to do 7/1 times 2/1 times 15/4. So 7 times 2 is 14 times 15 is 210. 1 times 1 is 1, 1 times 4 is 4. 210/4, we're going to divide 4 into 210. Come up with 52 then. Easy peasy. All right, so we'll do a few problems and then we'll get right into division. And division is really cool because if you remember back to when you learned how to do long division with fractions, you have to invert the number that you're dividing by. The number you're dividing by. Fraction you're dividing by, you have to invert. So you'll see that in just a minute. Meantime, let's do a few problems. So 3/8 times a half. That's a simple one. Somebody just do that out loud for me. Would you do it, Ben?
3 times 1. So
Yep.
numerator would be 3. 2 times 8, 16.
So answer's 3/16. Yeah, good. And then 4/13 over 5/16. John, can you do that for us?
So 4 times 5 is 20.
Hang on, before you do it, let's do some canceling because we can, right? What can you cancel in there? You can't cancel the 5 or the 13 because they are not divisible.
The 4 and 16.
Exactly. So the 4 is going to become a what?
1,
16 is going to become
a 4,
okay, so 1 times 5 is 5.
and then
13 times 1, I'm sorry, 13 times 4 is 52. So 5/52s, 550 seconds is the answer to that, without getting out and doing it on the board. We're going to try to do these in our heads. So, and actually, yeah, because they can't see this on the board, so fine. So we're not going to do it on the board. So let's do this one, and then we'll skip around a couple. So who wants to do this one? Raise your hand. Anybody out there in Zoom want to do this one? Anybody? No. Somebody? Okay.
You just cancel.
Okay, we'll do it together. Okay, so let's do some canceling. The 12 and the 32 we can cancel, right? The 12 and the 32 are both divisible by what? By 2. Yes, and they're also divisible. But you want so most things are any even number is going to be divisible by 2. You want to find bigger ones, right? So what's the next biggest number that they're both divisible by? 4. 4, exactly. That's going to be it, because obviously 5 doesn't work. 8 is not going to work. 8 goes into 32, but 8 does not go into 12. So let's cancel the 12 and the 32 using 4s. 4 into 12 goes 3. That makes that a 3. Okay, so what did that make 3? Okay, so 4 goes into 12, 3. and 4 goes into 32, 8, right? 5 goes into 5, 1, 5 goes into 25, 5. So now we're doing 3 times 1 is 3, and 5 times 8 is 40, 3 over 40, right? 3/40 is that answer. Let's skip that one and let's go to number 5. 1/32, 132 times 12/19. So the 1 and the 19, that's not going to be cancelable, but the 30 and the 12, what is 12 divisible by that 30 is as well? What's the number? Exactly 4. Wait. No, because we're not using 4 goes into 37.5 times. So they're big no.
32.
The same as.
Is it 32? Oh, shit, I'm sorry, I wrote 30 in my pad. That helps. Okay, so 4 into 12 goes 3 times, 4 into 32 goes 8 times. So now we're doing 1 times 3 is 3, and 8 times, until the bottom, 8 times 19 is what? 80 plus 72 is 152. So 150 seconds. Right? Am I right about that? 8 times 19? Yeah, 80 plus 72 is 152. See how I did that? It's a particular way of doing it by just breaking it out into, because my mind can't do 8 times 19. Although it probably could. It could go 8 times 20 would be 160 less 8, 172, right? Or, oh, I'm sorry, or it'd be 160 less 8 would be 152. But normally the way I would do that is 8 times 19 as I go. 8 times 10 is 80 in my head. That's an easy one. And then the easy times table is 8 times 9 is 72. I add in my head 72 and 80 is 152. Let's go to 8. Okay, so we're going to need to take that 3 and 3/16, and we're going to need to make it into a uncommon fraction. Both those numbers, we can't have mixed numbers. We're going to have improper fractions. So first thing we'll do is make 3 and 3/16 an improper fraction. What is the improper fraction? Say it again. It's 51, right? 16 times 3 is 48. Add the 3 makes it 51 over 16. And it's going to be times what? How many 12ths?
1
1,
of 19.
19. 12.
19 12ths, right? Times 19 over 12. Now, is any of this reducible? I'm not sure that it is. 12 and 51, well, no, I take it back. So 3 goes into 51 17 times, right? So I'm going to make the 51 17. 3 goes into 12 4 times. I'm going to make that 4. 16 and 19, there's nothing that's divisible evenly into those. So it's 17 times 19 equals what? And 16 times 4. 16 times 4, I happen to know, is 64. What's 17 times 19? Anybody?
Probably. Three, 2, 3.
323? 3, so 323 64ths, right? So what we do there is we do, on our calculator at this point, we would do clear, we would do 323 divided by 64 equals 5.04. So it's 5 and a remainder of 64. So I'm going to do 5 times 64. 5 times 64 equals 320. So it's 5 and 3/64. But 3 does go into 64. No, it doesn't. 3 doesn't go into 64. 3 goes into 63, right? It didn't go into 64. So that's your answer. 5 and 3/64 would be the exact answer to that question. Let's get a hard one. Okay, now we're talking. This is number 13. Number 13s are always hard. So first thing we got to do is what? And you know what? This is what we're gonna do. We're gonna do these problems on the board. We're gonna do a few problems on the board. Now, I'm gonna back up and do a few problems on the board, and then we'll go back to the book and project on the screen. We'll get into division. We're gonna do a couple of problems, and we're gonna do them on the board. So I'm gonna stop the share. I'm gonna pin myself. We're gonna turn the lights on. Turn that off. So the folks at home can see too. All right. Closer is better. Everybody got a book? And let's see where. Are we? Fractions, oh, we're way beyond that. So we're at number 13, right? Okay, so read me that quotient. 6 1/4
Times 3 3/8.
times 3 3/8
Mhm.
times
5 3/5.
5 3/5.
Yes.
Okay. And you're gonna see as we progress that there's a lot easier ways to do this. That's converting them to decimals, but that's fine. We're doing it this way. We're learning how to do it this way now. So we have mixed numbers, whole numbers and fractions. What are we gonna do? Change all these guys to improper fractions, right? So let's make that 6 1/4 an improper fraction. 6 times 4 is 24 plus the 1. That makes that 25/4 times 8 times 3 is 24 plus 3 is 27/8. Times 5 times 5 is 25 plus the 3 is 28/5. Now, can we cancel anything? Let's see.
Yes.
Nope, nothing there. Anything here? 8 times 5, no. Oh, we can do these guys though. Okay, so we can do a few here. We can do this one, make that 1. We can also make that 5. You can cancel all the way along, as long as it's as long as one on the bottom, one denominator and numerator can be divided by a number that is the same. What else we got here? We got 27 is in 3, so yeah, 8 and 28. That's good, right? So 4 doesn't go into 28, but 2 sure does. So 2 and 8 goes 4 times, and 2 into 28 goes 15 times. Just can't reduce that 27 at all, can we? All right, so it's fine. So we're going to be doing 5/4 times 27/4 times 14/1. So 5 times 27 is 135. Would you show that on a calculator times 14, please?
135 times 14.
Yes, 135 times 14.
1890.
1890 over 4 times 4 is 16 times 1 is 16. Now, would you please divide 1890 by 16?
No, decimals.
Okay, so what did it come out to? What's the whole number?
118.
Hun-
118.
And a decimal? Okay,
Uh-huh.
so fine. So now take 118 times 16.
118 times 16.
Yeah.
It's 1888.
Okay, so 1888 is 2 away from 90. So it's 2/16, which equals 1/8. So the answer is 118 and an eighth. See how we got that? It's just a process. Once you understand the process, the math is not that hard. And the better you get at doing it in your head, the better you'll get at doing it, period. And then once you've got it in your head, use your calculator, unless you're doing it faster in your head. I can do most sums fast, simple sums, like the stuff we do in carpentry. I can do most of the stuff faster in my head than it takes me to get a phone or a calculator and plug in the numbers. But then like the cubic yards and the stuff like, larger numbers. Phone or calculator, way to go. Let's do another problem. Let's skip to number 15. You know what? Yeah, we're gonna do one more multiplier. Do a really hard one.
But no.
You know
15?
what? I'm sorry.
No, number 15? No.
No, we're not gonna do those. We're not gonna do those because you guys have got the concept on that. I don't think anybody missed the concept on that. So let's just move along then, because I want to get to, I want to get into dividing fractions. So we're gonna move along. Moving. Okay. So still reviewing, use the staircase shown. Okay, sorry. Back and forth. Yeah, I love these hybrid classes. I wish you guys were all here, but I'm glad you can make it. Glad if you can't make it, I'm glad you're here on Zoom. Okay. Enough said. So we're going to use this staircase right here. Use this staircase for some problems that we're going to do right now. Number 20 question is using the measurement shown, which is 7 1/4 rise, and we're going to assume for the purpose of this argument that all the rises are exactly 7 1/4 and all the runs are 10 5/8. Did I tell you guys the ideal unit rise, unit run quotient? Set between 17.5 and 18.5. That is your ideal unit rise, unit run quotient, 17.5 to 18.5. You want to try to dial that. That's the best step. What's this one? 17 7/8, right in the money, right in there. 17 7/8. 7 1/4 plus 10 5/8. Now I did that in my head, but 7 and 10 is 17. And if I'm adding 1/4 to 5/8, I know that 1/4 is 2/8. And I know that 2/8 and 5/8 is 7/8. So what's the total rise from floor to floor? Well, let's count the rises. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 risers at 7 1/4. And since I know what the next question is going to be, so if there's 17 risers, how many treads? There's always one less tread than riser. There's always one less tread than riser, just like there's always one more joist than spaces. In this case, there's always one more rise than there are treads. So we know, one more rise than there are treads. So there's one less tread, so 16 treads at 10 5/8. Okay, so let's do the math simply. 17 over 1 times 7 1/4. 7 1/4 turned into a fraction. 4 times 7 is 28. That's the one's 29. So 29 quarters. And we cancel anything out. 4 does not go into 17 at all. No multiples go into that, nothing. So we got to do it the hard way. 1 times 4 is 4. What's 17 times 29? Somebody with a calculator?
17 times 29.
Yeah.
493.
493. And then 4 into 493 is going to go 123 times with a quarter left over. So the answer is going to be 123 1/4. See if I'm right, will you? Do 4 times 123. What is it?
4 times 1. Say that again.
4 times 123.
That is 492.
Okay, so I'm right. So the answer is 123 1/4. Did y'all see how I got that? Honestly, if you didn't, Say it again, please.
You explain on the board.
Yes, I can explain on the board, and I will explain on the board. Now, I think I will do it with the run. After we do the run, then I'll show you guys on the board. So let's do the run. And the run is the total run. We will need to, we know the unit run. It's 10 5/8. We know that there are 16 of them. So we're going to do 16 over 1 times 10 5/8. We got to turn 10 5/8 into an improper fraction. So 8 times 10 is 80 plus 5. That's 85/8. So we can cancel the 8, make it a 1. We cancel, it goes in 16 goes 2, and I'm going to show this on the board. So that's 2 times. So it's the answer is 170. 170 inches. And we can make that into feet too, can't we? Yeah. So 123 1/4 is 10 foot 3 1/4, and 170 inches is 13 something, right? Okay, let's show how we did those problems on the board. Thank you. The first one is the 17 risers. So we counted them. There's a picture of them, right? 17, we're going to do this as a fraction. 17 over 1 times, there's 17 risers, and there's 7 1/4, right? 7 1/4, which equals 4 times 7 is 28, plus 1 is 29.
Can't see.
So can we reduce? Doesn't look like it, does it? Okay, so that's right. We already did this and we're doing it again. So that equals something over 4. What was it? 493. 493? Okay. So it's because 17 times 29 is 493. And then we go 4 into that, right? And it came out to be 123 with a quarter left over. So it equals 123 1/4. And to prove that that's right, you just go 4 times 123. Well, 4 times 100 is 400. 4 times 23 is 92. So that's 492, and then we add 1. So we know it's right. And then the other one, at 10 5/8, we have 16 of them, right? 16 over 1 times 10 5/8. What do we have to do with the 10 5/8 to make it an improper fraction? To do that, we go 8 times 10 is 80 plus 5. So that 10 5/8 is actually 85/8. Cancel that because 1 goes into 8. 8 goes into 8 1 time. 8 goes into 16 2 times. Nothing else to cancel. 2 times 85 is 170 over 1. So the answer is 170. Any number over 1 is the number on top. It's actually any number over 1 is a whole number, but you can change any whole number to a fraction just by putting a line and putting a 1 below. But does that make any sense?
Yeah.
Okay. We're going back to the board, back to the board. Back to the book, back to the water. Okay. So we figured out the measurement, the total rise floor to floor. We did the total run by adding up the 16 treads. What's the ratio riser to tread?
The ideal,
No, well,
oh, here,
no, in any run, in any staircase run, What's the ratio to riser to tread? The ratio, what I'm looking for is there's always one more riser than there are treads.
Oh, good.
Total run, okay, so 27 rows of shingles, like that one. All that much. These problems are all okay. You guys can work on these problems. They may very well be in the test. I'm gonna, when I do test you on your midterm, I mean, generally, I'm gonna be pulling questions from the book. They'll be the stuff we've gone over through the book. And if I've thrown anything else your way, like what I'm about to do now, right now, then that'll be in there. So 12 3.5-inch vertical slats. That's not the line. You know what? It must be in division. There it is.
Follow third.
Yeah, I bet it is.
I think it's there.
Huh, yeah, it is. Okay. It's in division. And we're probably not gonna get to division. That's okay. You guys don't mind, do you? We to get to, are we in a hurry? Because I think we'll go through multiplication and I'll answer some questions and then we'll go, okay? Unless you guys, well, I'll stay for the whole time if you want to. Raise your hand if you want to stay for the whole time. Raise your hand if you want everybody else to kill you. Ben wants to stay. Raise your hand if you want everybody to jump you.
Right? Okay, there we go.
Sorry. Okay, so yeah, let's do some of these. All right, we'll do this one. We'll do this one right here. So we're going to use this fence to answer some questions, 25 and 26. The fence as shown. 12 3.5-inch vertical slats are installed between the support posts with 1/4-inch spacing between each slat and between the slats and the posts. How far apart are the posts? So 12 slats is going to give you how many spaces?
11. No. 13. 13.
One more.
Now, there's always going to be one more spaces than there are slats. Same thing with balusters. There's one more space than there's balusters. So we know that if there's 12 slats, it's 12 times 3.5. That's going to be one of our things, right? And then 1/4-inch spacing, there's 13, right? So 13 times 1/4. So by getting the products of those two problems, the 12 times 3.5, and then the 13 times 1/4, and we add those together, we should find out how far apart the posts are, right? So let's do it. So 12 times 3.5, well, I'd like to just do that in my head. It's so damn easy. It's 42.
30.
It's 42. And this is that's how fast my mind works. But remember, I'm 73 years old and I've been doing this for probably 50 plus years. So I don't expect your minds to have what my mind's got in it just by virtue of being on the planet longer. So don't feel bad if this is not jumping into your head. I've had a lot of practice to make this happen. So let's just do it longhand. So 12 times 3.5 is 12 over 1, since we're learning how to multiply fractions, times 3.5. 3.5 is an improper fraction, is represented how? 7 2s, right? 7 over 2. So we can cancel the 2 and make it 1. We can cancel the 6 at the 12 and make it 6. 6 times 7 equals 42. Didn't I say 42? Yeah, I did. It's 42. So that's how long 12 3.5-inch slats are. Now the spacing, 13 times 1/4. So 13 over 1 times 1/4. We don't have to change a 1/4 because it's not a mixed number. It's a fraction. So and there's nothing reducible. So it's 13 over 4. That's 13 quarters. How is that a whole number? What's the whole number? I'm sorry, not a whole number, but a mixed number. 13 quarters represented as a mixed number is what? 3 1/4. 3 1/4 plus 42 is what?
45.
45.
45 and 1/4. That is post to post. You know, and if you were doing this practically, I'd build this on the bench. I wouldn't build this. But that's when we get to the baluster spacing thing. Okay, so that's what we'll do. We're gonna go through these problems. I'm gonna just talk at you for a little bit, and then rather than take a break and come back, we'll go 10 more minutes, maybe 15 minutes. We'll go home. Okay, so 26 says now they're telling us that there's 12 7 1/4 slats. So 12 over 1 times 7 1/4, and that 7 1/4 equals what?
29.
Exactly. So an improper fraction, 7 1/4 as an improper fraction is 4 bottom number times 7, 28 plus the numerator on top. 29/4 times 12 over 1. So let's see, can we reduce anything? Yes, we can. The 4 goes into 4, 1, 4 goes into 12, 3. So then now we multiply across. 3 times 29 happens to be 87. And 1 times 4 is 4. So it's 87 over 4. And the reason why I came up with that 87 so fast is my mind went to 3 times 30 is 90. Take away 3, 87.
Wouldn't it be 87 over 1? Because you reduce.
Oh, I'm sorry. You're exactly right. It's 87 is the answer. So yeah, it's 87 over 1. I forgot to see that I crossed out before. I made it a 1. So yes, it's 87. And when you can reduce and get those bottom numbers to a 1, you're golden, because then you just have to do the multiplication on top, and that's the answer. If that bottom number, the denominator is 1, the numerator is the answer. There is no fractions. So what's the next one? A set of porch steps consists of 6 risers measuring each 7 9/16. How far above grade is the porch? Well, it sounds like they want us to multiply 6 over 1, because we're going to make it a fraction, times 7 9/16, which we have to make into an improper fraction. Can you tell me how many 16ths 7 9/16 is? It's 105 over 16, right?
I was gonna say 121.
I'm saying 105 because 7 times 16, 7 times 10 is 70.
70,
7 times 6, oh, you're right. I'm wrong. Totally wrong. So let's do this again. 7 times 16 is what? 112, right?
12, yes.
Yeah. So 7 times 16 is 112, and add the 9. 112 and 9 is 121. So it's 121 16ths. So the 6 and the 16 are next to each other, are opposing each other. So what goes into 6 as well as 16? What number?
2.
Exactly. 2 goes into 6 how many times?
3.
And 2 goes into 16 how many times?
8.
So I changed that 8 on the bottom. So multiplying across the bottom, 1 times 8 is 8, and 3 times 121 is 363. And then 8 into 363 is, should be what? 40, and then 40, and then 40, and then 43. 8 into 43 goes 5. So it should be 45 and 3/8. Is that right? Is 363 over 8 45 and 3/8? Somebody tell me yes or no?
So I'm just working on the final result. I'll let you know if I get the same.
Okay, so do 8 times 45 for me.
8 times 45 is 360.
Okay, so the answer is 45 and 3/8. And it's just me taking the easy answer, which is 363/8, which is an improper fraction, and making it a mixed number. And to do that, I just divide the 8 into 363. I can kind of do that in my head fairly easily. 8 times 45, I know is 360. Because I know 4 times 90 is 360. Because I know a circle is 360 degrees. And there's 4 90-degree arcs in that circle. That's the way my mind works. So 45 and 3/8 is the answer. We all got it. I'm stoked. What else? Oh, retaining wall. It's to be constructed out of 5.5-inch thick blocks. I'm assuming they mean high when they say thick. I guess thick, deep, wide, deep, thick. So they're 5.5 inches tall, I'd say tall, by 9 rows high. Well, really the way to do that is 9 times 5 is what?
45.
I'm sorry, 9 times 5 is what?
45.
45. I thought you heard you say 25. So that's pretty easy. 9 times 5 is 45, right? Now we need to do 9 times 1/2 inch. What's half of 9? 4.5. So when you multiply anything times 1/2 inch, just have it, right? So what's 50 times 1/2 inch? What's 50 times 120? Oh yeah, I'm sorry. What's 120 1/2 inches? 60 inches. So I wouldn't bother writing that down. I'd just go 45 plus 4.5 is 49.5. It's 49.5 tall. Cap shingles are applied to the ridge of a house. You know what those are? It's a ridge cap. So the shingles go, we start at the bottom, shingle up. Each layer of shingles goes over the next layer, goes over the next layer, making it waterproof so they shed over and shed over and shed over. And then when you get to the top, you got a ridge, and that gets a cap. It gets a ridge cap. So cap shingles are applied to the ridge of a house with an exposure of 5 3/4 per cap. How long is the ridge if the roof is 90, if 96 caps are used? So obviously the problem is 96 times 5 3/4. So same thing. 96 over 1. Let's turn 5 3/4 into an improper fraction, mixed number to an improper fraction. 4 times 5 is 20, plus the 3 makes it 23/4. Now, we can make that 4 turn it into 1 on the bottom, and the 96, 4 goes into 96 how many times? 24 times, exactly. So we got 1s on the bottom, which is great. So all we got to do is 23 times 24. Anybody know what that is?
552, I got.
There you go. That's the answer. 552, whole number. As long as you got 1 on the bottom, if you're able to cancel and get that 1s across the bottom, you know the top number is a whole number, you got no fractions. Everybody likes even numbers, just life is messy. Even numbers are rare. When's the last time you had an even number at the checkout stand? Remember Trader Joe's used to like ring a bell and give you a prize? You remember that?
No.
If your total at the register at Trader Joe's came out to an even number, you got a prize. You got like a bag, or you got to throw the little ball. None of you remember that? I know you were born. I know you were all born.
Is that what they do when they ring the bell? I hear it.
That's something else
Oh,
now.
that's something else.
But they used to give you a basketball, a little Nerfy ball, and they had a basketball hoop, and you could throw it. If you got it, you got a bag.
Huh.
Trader Joe's bag. They stopped doing it. Just like Rancho stopped giving out water. So I'm a golfer. I am. Golf is my passion. I just love golf. I feel like I don't know what I'd do without golf. It's the hardest game I've ever played, and I've played a lot of games. It's the hardest game I ever played, and it's the most satisfying and the most frustrating. It takes the longest. It takes 4.5 hours to walk the golf course, to play it, run golf. It's beautiful. I've been on beautiful courses. Why am I telling you this? Damn, I started out with a really good reason. Totally long. So Rancho San Marcos is one of my favorite golf courses, and it's been closed since COVID. and they're not gonna reopen. As a matter of fact, a for sale sign just went up. So it's right around 300 acres. It's 398 and change acre parcels. It's either side of the San Ynez River. There's steelhead in the river. I've seen bald eagles, bobcat, wild turkeys, deer, just fox, coyote. It's just a phenomenal golf course. And it's going away, man. And it's advertised for 12 million, which doesn't seem like all that much. But they're not even advertising it as a golf course. You know, they're advertising it as a piece of property, like somebody would want to buy a golf course and live on it. It's the dumbest thing I've heard today, but well, I heard it early today, so there's been a few dumb things since then. But any of you interested in buying it? I know some of you know people with 12 million chump change. So please, would you buy it? I hate to see that golf course go. Oh man, has anybody ever played golf there? Okay, so any of you golfers?
That's a good goal.
Dad's a golfer. Okay, so I hit my 5 wood anywhere from 160 to 200 yards, depending upon how hard I swing, what the wind's doing. Kind of damn heavy. It's a pretty versatile club. It's probably my favorite club. And it's an older club. It's Callaway VFT, which means variable face thickness, whatever the hell that means. But I teed up on hole number 5, Rancho San Marcos. This is about 3 or 4 years ago, maybe 5 years ago. And it's a 185-yard hole. And it's over water. It's all over water. Like the tee's here, and by the time your ball gets to that wall, it's over water, and it's over water the whole way till the green. So it's all carried. And then you get this gigantic green that's trapped, and then a giant oak tree and a hill, kind of a backstop hill. I hit that 5 wood, just land. It was just it was a perfect high draw and a roll towards the hole. And I thought, God, it looked like it won the hole. And guess what? Yeah, it did go in the hole. That was a hole in one. It was, and I've had 2 holes in ones. And that one, you know, most people's holes in ones are on par 3s, which is this was. But most par 3s are shorter. They're 100 yards, 120, 130, 140, 150. You get into 185 and 200 yard par 3s, they get a lot harder to get even close, get on the green. So it was a phenomenal time. Can't believe they're closing this golf course, but they are, and that's that. Nobody's going to get to play it anymore.
You think it has to do with water?
It has a lot to do with water.
You'd be able to put like.
But you know, but different than what you're thinking. What it really has to do with is that when they bought that land, the people they sold it to them didn't sell them the rights to the water. And they thought they could make it work with surface water. And a couple of shallow wells they had or something. They have a couple of shallow wells, but they don't have the rights to the water. They can't tap the groundwater. So they would always run out of water. They'd have to buy water, truck in water. They just had this whole water problem. And then, you know, COVID. Plus, you gotta remember who owns Rancho right now. Actually, I don't know if he owns the land even, but he owns the golf course. And that's Ty Warner. Why is Ty Warner kept the Biltmore closed? Why is it still closed?
Because they're not extending the contract with the Four Seasons. And
Yeah, but still in all, he's got this
open
incredible property.
Yeah.
He's got all these employees who are furloughed for almost 2 years. And he's got, I mean, can you imagine what that property loses every day? It's not operating.
He's opening his own hotel.
He's what now?
He's opening his own hotel.
He is? That's this.
He kept it closed to like so the Four Seasons contract would run out.
Oh,
And that
okay.
he could
So
open
that's
his own.
what, that's the skinny. Oh,
He's
that's,
gonna open his own.
oh, that's great.
So he doesn't
Thank you
have
for
to
telling me
pay.
that.
You also own Sandpiper.
Say again, please.
You also own Sandpiper.
Oh, really? Really? Honestly? You think I didn't know
Yeah.
that? So, you know, Ty had a very ambitious plan for Sandpiper. 10 years ago, he wanted to close it for 2 years and spend $20 million and completely redo it, turn it into the Pebble Beach of the South. He wanted to put the clubhouse down by the ocean and completely reorient everything and take more advantage of the fact that it's on the ocean, right? This beautiful plan. And he spent tons of money developing this plan. And, he had Tom Fazio, I think was the golf course architect, was involved in all this stuff and all these public presentations. I went to all 3 public presentations and was a vocal, very vocal, it's not proponent, but I was really against. And for a really simple reason. My first question was, how much will it cost me to play golf here when you're all done? When you spend 20 million bucks and you close it for 2 years, how much will me, the local, how much will it cost me to play golf? And will I be able to just come out anytime and play golf? Well, we haven't really gotten it. You're willing to spend $20 million and you spend all this money and you can't tell me how much you're going to charge for a round of golf? That's just not true. So they wouldn't tell me. Guess how much it costs to play Pebble right now? $575 for a round of golf. And you have to stay at the inn, which is $800 minimum. That's their cheapest room. So a round of golf is going to cost you a minimum of $1,375 for a round of golf. That's just sick, man. So anyway, me and a bunch of other people, don't change it, man. We don't want you to change it. And they didn't change it. I'm really glad they didn't change it. Following sheet goods are delivered to a wood shop. 22 3/4 OSB. Who knows what OSB is?
Oriented
OSB
stranded board.
Say again?
Oriented strand board. Stranded board. Oriented.
That's good. Who's talking?
Ben.
The mass, I can't tell. Oriented strand board. It's got strands of fiberglass running through it. It's a lot of glue and chipboard. It's cheap. Delaminates like crazy, but it's used a lot. I don't particularly care for it all much, but so 22 3/4 OSB, 24 5/8 plywood, and 18 1/2-inch plywood. What does the stack measure if all the sheets are placed on top of each other? So we got to do. Is this the last one? Okay, we'll do this last problem. We'll turn on the lights. I'll talk for a couple of minutes and then we'll go. So wait, before you turn them on. Oh yeah, go ahead and turn them on. Keep them on. I mean, keep them on. Keep them on. We'll get rid of this. We'll bring the folks at home over to the pin. New gallery. Pin me. Okay, that last problem. The following sheet goods. Somebody got the book? Can you read me the problem?
The following sheet goods are delivered to a wood shop. 22 3/4.
Okay, so we got 22. How thick?
3/4.
And then we've also got, what's the next one?
24 5/8.
24 sheets of 5/8?
Yeah,
24 sheets of 5/8.
and 18 of 1/2-inch.
Okay. So let's do some canceling. 2 goes into 4 how many times? 2 goes into 22 how many times? Exactly. 3 times 11 is 33. 1 times 2 is 2. 2 goes into 33 how many times? 16 times with 1 left over. So 33 over 2 equals 16 1/2. Okay. So what can we reduce here? This is a great one, right? 1, 8 goes into 24 3 times. So it's going to be a whole number. 3 times 5 is 15. This one, good canceling. 1, 2 goes into 18, 9. 1, another one, 9. So 16 and 15 is 31. 9 is 40. Yeah. Piece of cake. Okay, so does anybody have any questions about fractions or multiplying fractions, any of the stuff that we've been talking about? Anybody have questions about golf, about what a hook or slice is? You know, like that? No? I killed my buddy yesterday. I've known this guy, the guy I played golf with yesterday at Buenaventura. I've known him for 60 years. Yeah, we've been friends for 60 years. And so I know him pretty well. And he's a Jewish guy, he's small, he's just a great guy. He's a landscape architect, he's retired. He hates to lose money. You know, we don't play for a lot of money. He hates to lose money. So last Saturday, I took 15 bucks off of him, and yesterday I took 15 bucks off of him. And you'd think that I stole his house or that he lost his car. He's so bummed, man. I swear to God. It's cool. There's nothing like taking somebody's money when it really hurts them. Even though it doesn't really hurt him, right? But oh my God.
What is a round? What is a round of?
A round of golf? What is it?
Yeah, right, because you were saying that the cost of
Oh,
one would be
okay.
close to 13.
So a round of golf is 18 holes of golf.
So that means you would spend all that money just in 4 hours of game or 5 hours?
4.5 hours a game, you'd spend $1,375 bucks. And I was talking to a guy at the car wash the other day that said, talking to a guy at the car wash, that we were talking about Pebble Beach because I played Pebble Beach a couple of times on somebody else's dime. And then I played on my dime in October, April? What is this? Must have been April of this year. I played on my dime this year, but they had punched and aerated. So once a year, sometimes twice a year, they punch the greens with these little like 1/2-inch holes about every 1.5 inches. They pull the plugs out and then they fill them with sand, and it's aeration. Sometimes they vertically aerate them, but it aerates the greens and makes them come back better. But they're really hard to putt on then, because you've got all these little holes filled with sand. So, and that's what they were yesterday. But at Pebble Beach, I got to play for $385, and I didn't have to stay at the lodge because they had punched. And it was like 2 or 3 weeks at the end of that, so the greens were almost back to perfect when I got on. I played with 3 really good friends of mine. I have 31 years of sobriety. All 3 of my friends have 30+ years of sobriety. So we're all, sober guys for a long time. So we had a lot in common, and we're all about the same age. And of course, I beat them all so bad. I beat them like stepchildren. But Pebble Beach, this is how cool it was. Hole 17, it's a par 3, and you're driving from the tee to the green. It's super well trapped, lots of sand traps, and then beyond that is Monterey Bay. And out in the Monterey Bay is a pod of orcas, killer whales, breaching, and over here about a 1/2 mile away, a pod of humpback whales. It was insane. It was so pretty. And then walking up 18, you got the ocean on your left, and then my wife and dog were there to meet me. They let them on, the great stuff. It was the greatest. Now, what was I telling you about?
Price,
Say
the
again?
cost? Weren't you talking about the cost? Or
The cost?
no, you?
Oh, yeah, but I got on for a deal, and I had played a bunch of times before where Hayward's has taken me, lumber company has taken me to some pretty good golf places. But yeah, I love golf. So how's everybody doing this math thing? I know a lot of this for some of you is really basic and simple and easy. And I'm okay with that. Hopefully you're okay with that, because I gotta take the whole class along, and I want us to get really solid on the basics, and then we'll get into some more stuff, and we'll tie it more and more. And thanks to Ben for bringing us that problem. And if you have any real life problems, bring them, because they illustrate what's going on way better than anything book or I can dream up for you. Yes.
We could do a takeoff for that foundation and the shade structure.
Good idea. Let's do that. We'll do a takeoff. I can revamp those drawings. Let's you and I talk, and I can revamp that drawing. So let's show the 6 foot.
Yeah.
And then we can do a takeoff on that. That'd be a good idea. We can use math to do that for sure.
For the company.
Yeah, for the concrete and for the square foot of the, the roof and the shot. And anything we have to add up, we'll try to get some fractions in there. And also, I really want to show you these drawings. I'm working on these drawings right now. And I was going to bring them tonight, but like I said, I'm wait till I get them done so you can see how anybody, I'm not trained as an architect by any stretch of anybody's imagination, but how anybody with just a little bit of knowledge of how to draw to scale can actually create something, a real drawing that can really be built. Like I'm drawing a thing for a guy's kitchen. He's going to spend 50 grand on his kitchen. He's going to spend it based on my design. And so today I'm crunching like fractions. I'm crunching lots of fractions and seeing if I've got the 90 degrees for a door opening, and if I can get a lazy Susan to do its turn inside this cab, just a whole bunch of stuff that I'm using the math that I've used all along to make this all work, because I am building it on paper. And if I make it work on paper, I'm convinced the guys in the field can make it work. If I can't make it work on paper, and I'm pretty sure they can't make it work in the field. And so, and you can imagine the difference between creating something from a bunch of hand waving and verbalization versus a concrete plan. And that's the difference. Hand waving and verbalization, it's everywhere. It's like you go to somebody's house and they go, yeah, I want to go like this. And then over here, I want this. And they just describe all this stuff to you like it means something, and it doesn't. See, I think in plan view. When I think about something, I think in elevation after plan view, but I think in bird's eye looking down on it. And so when I'm in a room, I can get a sense of the room, but I don't really get a feel for the room and what goes in it in terms of built-ins and specifically cabinetry until I've got it, the room on a scale drawing, the largest scale I can fit. And then I can really start making it all work. And it's a little like magic, but it's not. It's numbers, and numbers don't lie, man. Numbers are real, and they'll tell you the truth every time. So until next week, be safe out there. Be careful. And Dylan, look at I bought from Dylan about this beautiful Paducah ant. Huh? Only $105.
Thank you, Rodney.
See ya.
Hey, and Zoom people, Thank you, Rotary.
They're all gone.
No, they're probably gone. Zach's the
The
only
two of
one
us.
here. Zach's the only one here. Okay. Stop it.